scientists just cracked the greatest water engineering mystery in history. For 800 years, nobody could explain how 1 million people survived in a jungle with no rivers. The answer was hiding beneath the trees. And it changes everything. In the heart of Cambodia's jungle lies something that shouldn't exist. A city that once housed more people than medieval London, Paris, and Rome combined. But here's what baffled archaeologists for over a century. There's no major river here. No natural lake. The monsoon season brings devastating floods, and the dry season brings months of drought. So how did the Khmer Empire sustain over 1 million people in these impossible conditions for 500 years? The answer lay hidden beneath centuries of jungle growth. And when researchers finally found it, they discovered the most sophisticated water management system the ancient world had ever built. But that discovery raised an even bigger question. One that modern engineers still can't fully answer. How did medieval builders, without computers, without modern surveying equipment, without even basic steel tools, create a hydraulic network that would put modern city planners to shame? Let me put this in perspective. The Roman aqueducts are considered one of humanity's greatest engineering achievements. They moved water across 50 miles to supply Rome's 1 million residents. Impressive, right? But the Khmer water network at Angkor spans over 1,000 square kilometers. That's larger than modern-day Los Angeles. And we didn't even know its true scale existed until 2012, when Australian archaeologist Damien Evans pointed an aircraft-mounted laser system called LIDAR at the jungle canopy. What he saw changed archaeology forever. Beneath the trees lay an invisible metropolis. Hundreds of kilometers of canals. Massive reservoirs called barrages, some stretching 8 kilometers long. Channels connecting distant mountains to city centers. And all of it, every single kilometer, was carefully engineered to control something that destroys modern cities every year. The monsoon. If you're learning something new, that like button helps more than you know. But here's where it gets strange. The Khmer didn't just build a water system. They terraformed an entire landscape. Think about that for a second. Today, reshaping terrain on this scale requires satellites for surveying, computer modeling for water flow, heavy machinery for construction. The Khmer had none of this. They had bronze tools. They had elephants. And somehow, they moved enough earth to fill the Great Pyramid of Giza 25 times over. University of Sydney researchers spent a decade analyzing the network's gradient. The entire system drops just 1 meter over 10 kilometers. That's a slope so subtle, so precise, that modern engineers need laser levels to achieve it. Yet the Khmer maintained this gradient across their entire network. Without modern instruments. Here's what keeps archaeologists awake at night. We still don't fully understand how they surveyed it. Now imagine you're a Khmer engineer in the year 900. Your king wants to expand the capital. You need to supply water to 100,000 new residents. But you can't just build more canals. The monsoon delivers 90% of your annual rainfall in just 4 months. Build the channels too small, your city floods. Build them too large, you can't fill the reservoirs during dry season. Get the gradient wrong by even a fraction, water stagnates and breeds disease. This is where Khmer genius becomes apparent. They developed what modern hydrologists call a cascading overflow system. Multiple reservoirs connected at precise heights. When one fills, it automatically spills into the next. Too much water. The system redirects excess to flood plains outside the city. Too little. Gates control flow from the massive West Barrage, their primary reserve. It's the same principle behind modern smart grid water management. They invented it 800 years ago. But everything I've told you so far, that's just the beginning. Because the real mystery isn't how the Khmer built this system. It's what they built it on top of. In 2015, LIDAR revealed something nobody expected. Beneath Angkor's visible network lies another, older system. An engineering project so massive it took 4 centuries to complete. And it wasn't built by the famous kings who constructed Angkor Wat. It was built by rulers we've never heard of. Generations of engineers, working across lifetimes, each one adding to their predecessor's work. They carved channels from mountains 30 kilometers away. They created artificial lakes that didn't exist in nature. They literally reshaped the hydrology of an entire region. And here's what blew my mind when I first researched this. The oldest channels date to the 6th century. But Angkor Wat wasn't built until the 12th century. That's 600 years of continuous hydraulic development. If you want to see how this incredible story ends, make sure you're subscribed. Now let's talk about something archaeologists don't often discuss publicly. The West Baray. This is the largest artificial body of water ever created in the pre-industrial world. 8 kilometers long. 2 kilometers wide. Holding over 50 million cubic meters of water. That's enough to fill 20,000 Olympic swimming pools. And here's what makes this genuinely incredible. Modern satellite analysis shows the Khmer cut through solid bedrock to create uniform depth throughout. They lined sections with clay to prevent seepage. They calculated evaporation rates and adjusted intake channels accordingly. We know this because the Baray still holds water today. After 1,000 years. Without any modern maintenance. Fletcher's team at Sydney University ran the numbers. To build this with modern equipment would take 3 years and cost over $200 million. The Khmer did it with human labor, elephants, and bronze tools. The engineering margin for error? Less than 0.3%. So here's the question I promised to answer. How did they actually do it without modern tools? After 15 years of research, we finally have an answer. And it's not what you might expect. The Khmer used water itself as their surveying tool. Here's how. They would flood a construction area with shallow water. Perfectly still water naturally finds level. Any variation in the ground becomes immediately visible as changing water depth. Workers would then mark high points, remove excess material, and repeat. Over and over. For decades. This technique, called water leveling, requires no technology whatsoever. Just patience measured in generations. They also developed something archaeologists call the moat method. By digging interconnected moats around construction sites, they could transfer levels across vast distances. If water flowed between 2 points, those points were connected. If it didn't, they kept adjusting. Simple. Brilliant. And absolutely effective. But here's the part that keeps modern engineers fascinated. The system wasn't just engineering. It was adaptive engineering. Climate records from tree rings and sediment cores show the Khmer faced the same problem we face today. Climate change. Between 1100 and 1200 CE, Southeast Asia experienced a series of megadroughts. Rainfall dropped by 30% for decades. Then came megamonsoons. Floods that modern records have never matched. The Khmer water system survived both. For 300 years, they adapted. Expanded reservoirs during drought periods. Added overflow channels during wet periods. The network grew, evolved, responded. But then came the 15th century. And something went wrong. The system that had sustained civilization for 5 centuries suddenly failed. And the reason reveals a warning that modern cities desperately need to hear. The conventional story says the Thai armies destroyed Angkor in 1431. But that's not what the evidence shows. By the time invaders arrived, the city was already dying. Here's what actually happened. Over centuries, the Khmer expanded their network beyond sustainable limits. Each king wanted bigger projects. Longer channels. More impressive berets. But they also cleared more forest for agriculture. Trees that had anchored hillsides for millennia were gone. When the megamonsoons returned in the 15th century, erosion devastated the network. Sediment clogged channels faster than workers could clear them. Reservoirs filled with silt instead of water. The cascade system that made Angkor possible became its death sentence. Overflow channels meant to save the city spread sediment everywhere simultaneously. One catastrophic season could destroy decades of infrastructure. The engineering that sustained 1 million people couldn't survive the consequences of its own success. And this is why modern hydrologists are studying Angkor more intensively than ever. Cities like Bangkok, Mumbai, and Jakarta face identical challenges. Extreme monsoons alternating with droughts. Massive populations dependent on engineered water systems. Infrastructure pushed beyond original design limits. The Khmer lesson is clear. Brilliance in engineering means nothing without sustainability in management. Modern engineers have identified specific features at Angkor that we should replicate today. The multiple redundant channels. The cascading overflow design. The integration